Section 1.5, and we're dealing with surds. Now, I'm going to assume that not everybody has watched this playlist from the start, and I'm going to just repeat a bit of the advice from there. This is material which you have seen at GCSE, but at GCSE it was difficult. Now it needs to get to the point where it's easy, okay? It needs to be something which you can do without thinking about it. The mistake a lot of people make is they start the course at A-level, they think, oh, I can do this, I've seen this at GCSE, it's just surds, and they don't put in as much practice as they should, and then later on you get stuck, and that's perhaps why you're coming to this video. You're coming back and thinking, oh gosh, I don't understand surds, and now every time I get a question with surds I'm getting stuck, and it's later on in the year, and you're out of control. If that's the case, don't panic about it, it's not the end of the world, but what you do need to do is just come right back to here, practice the surds. You're not going to get good enough and smooth enough at surds without putting the practice in on these exercises, and it's worth doing lots of the examples. I've said in the first video that I advise my classes at least half the questions, and that's if you're feeling confident, okay? And then every question on the mixed exercise is my advice. If you've done exercise 1E and exercise 1F, and you're still thinking, actually, I don't really get these surds, I need more practice, ask your teachers. There's loads of books out there with lots of surds examples exactly like this, but it really is worth putting in practice to the point where they're really easy, right, where they're really simple. So if you're looking at exercise 1E and exercise 1F and you're thinking, actually, they'd take me ages to do those questions, then you're not yet good enough at surds to do the whole AS level course, right? You need to look at exercise 1E and think, oh, well, I could do that in, between 5 and 10 minutes. It's not going to take very long because these are things that you practiced. I don't expect everybody to be thinking that at the start of the course. Very few people will be thinking that they could do it that quickly. But the point that you need to be aiming for with this particular material is the point where you can do it so easily that it's just not a problem. It's like doing times tables, or it's like doing adding decimals or something like that, right? It's not. You need to get it to the point where it's not easy. If you're not there yet, the answer is practice, okay? Don't panic if you're not there yet. It doesn't come naturally to most people. Most people wouldn't see an exercise like this at the start of an A-level course and think, oh, I can do that in 7 or 8 minutes. Most people think, actually, that's going to take a while. But if you're coming back and revising it, you should then be thinking, oh yeah, I can do that now. Now it's quick. If you are coming back and revising it and you're still not thinking it's quick, don't panic. Again, just put the practice in now, all right? So, where are we? Let's get back to the rules. Let me just, you can read those 2 rules for yourself there. Let me just remind you, the square root of a plus b is not the same as the square root of a plus the square root of b. And we can see that by just picking 2 numbers. The square root of, well, let's say square root of 9 plus the square root of 16. Well, that is 3 plus 4, that is 7. The square root of 9 plus 16, well, that's the square root of 25, and that is 5. So those 2 things are different. If that is a plus sign there, you can't split it up into 2 separate roots, but it does work if you've got 2 things multiplied together or 2 things, one divided by the other in the brackets. It doesn't work if it's a plus, doesn't work if it's a minus sign. So watch out for those ones. And again, I'm sure lots of people have fallen into that trap before of having a square root like this and then just deciding you can split it up. Well, you can't, it won't work, all right? Now, let's see, simplifying surds then. For example 1E, before we get onto rationalising denominators, for example 1E, there are kind of 2 things to do, right? The first thing is treat the surds as though they are x's and y's, okay? That's the first thing, treat them as though they're x's and y's. And the second thing is just remember that the surds aren't, once you treated them as though they're x's and y's, then just remember that they also have some special properties as well, right? So for example, this one, if that was an x times 5, then, well, if these were x's and y's, just expand the brackets. 5 times root 2, and then this times this is minus root 2 times root 3. Okay, I've got as far as I can treating them as though they're x's and y's, pretending that they're algebra. Now let's look at the special properties the surds have got. Well, 5 root 2, can't do much with that. Root 2 times root 3, we can write as root 6 if we want. So just to, oh, that's a 2 there. Just to simplify it as far as we can, that's as far as we can get, okay? and I'm starting with example 13 here. Obviously, I'll go back to example 12 in a second. So 2 minus root 3, 5 plus root 3. Treat them as though they're x's and y's. So 2 times 5 is 10. 2 times root 3 is 2 root 3. 5 times root 3 is minus 5 root 3. Minus root 3 times plus root 3 is minus root 3 squared. Okay? Keep treating as though they're x's and y's. 10. 2 of them, take away 5 of them, is minus 3 root 3. And now, look, root 3 squared, well, by definition, that is 3, isn't it? So that's where we end up with 7 minus 3 root 3. So to get to here, I've just treated the square roots as though they're x's and y's. For these two terms, same, just pretending they're x's and y's. And then this is where I've used the special property of the square roots. Okay, so that's the first approach. And then the other sort of special trick we can do, I'll take an example from the exercise here, square root of 72. Well, if I write that as, oh, I see I've done this, it's foolish, wasn't it? I've taken the square root, so here we go. Square root of, if I write the square root of 9 times the square root of 8, so I was struggling to think of the right factorisation there. Well, 9 can be written as, square root of 9 is the same as 3, okay? So 3 square root of 8. And then let's try and do the same thing again. Well, square root of 8 can be written as square root of 4, square root of 2, and the square root of 4 is 2. So 3 times 2, square root of 2 is 6 root 2, okay? So that is the special power that surds have got. There are 3 examples. Root 2 times root 3 gives us root 6. Root 3 times root 3 gives us 3. And then the other thing is, when you've got a surd like this, you can factorise the number underneath the surd in a clever way so that you can make the surd simpler. Now let's think about that factorisation. What you need to do is think of 2 numbers that times together to make 72, but if it's going to be any use, one of those numbers has to be a square number. So don't think of the factors of 72. 72's got a lot of factors, right? 1 is 72, 2 and 36, 3 and... so dear, 3 and something or other. 3 goes into 72 sometimes, isn't it? I don't know. Sorry, having a bit of a brain freeze, but you get the idea, right? There's a lot of numbers that go into 72. But what are the square numbers that are smaller than 72? Well, 1, 4, 9, 16, 25, 36, and already, look, we're up to half of 72. So those are the only square numbers that we've got to check. 1 isn't going to do us any good anyway, so we've only got a small list of square numbers to check. All right? So if you're trying to do this simplifying of surds, you're looking for factors which are square numbers. And the more useful fact there is the square numbers bit, okay? Look for square numbers that fit into that number rather than listing the factors and then checking if any of them are square. As again, rule of thumb, bit of advice. It's not always going to work that way around. Have a look at example 12, part C here. Now, if this is going to simplify much, what you'll get used to in examples like 12, part C, or in the exercise, things like J, K, L, if you've got lots of different terms and they're all different surds, what will often happen is when you've simplified them, it turns out to be the same surd, right? So in this example, I'm looking at it and I'm saying 5 root 6. Well, root 6 doesn't have any factors that are square numbers, so I can't simplify the root 6. Root 24, well, 24 does have a factor that's a square number. 4 is a factor of 24. And if I factorise that by 4, then I'd have a root 6 left. So I've got a root 6 here and a root 6 here. Okay? So when I'm looking at 294, before I've even looked at the number, I'm already expecting it to have a factor of 6, and I'm expecting it to be 6 times by a square number. Okay? Because then that square number will simplify and I'll be left with a root 6 and all 3 of these terms will collapse together. Now, maybe 294 is too easy a number. Maybe you could see automatically that is 1/6 less than 300, and obviously 6 fits into 300. So maybe that was too simple. But looking at these ones here, 18 is 9 times 2. Okay, so the 9 is going to simplify, the 2 isn't. So I'm going to expect there to be a root 2. So when I've dealt with the 18, I'm expecting this number and this number, whatever they happen to be, to have a factor of 2, and the other factor that pairs with the 2 is a square number. All right, so use the terms around to help you. And I think that's all there is to say about that particular section. So we'll talk about rationalizing denominators in the next section.